This is lesson 12-4. My assistants today are Stacey and Jacob Van. Let's start, Jacob Van, by reading them that first theorem. I think it's 12-13. Will you read that?
Yep. The measure of an angle formed by two lines that intersect inside a circle is half the sum of the measures of the intercepted arcs.
So what Jacob is saying here is that if you have an angle with its vertex inside the circle, just somewhere in the interior, we have a rule for that. We've already done the rule for if that vertex is exactly on the edge or exactly in the middle. What if it's just like somewhere in the interior? Jacob has read us the rule for that. I think you can see that this angle right here would catch more arc here than its back does here. Yet those two angles have to be the same, don't they? They're vertical angles. But they are going to catch different size arcs if this is not in the middle. So the rule Jacob says is they will be equal to half the sum of what you catch front and back. Half the sum. So if you have maybe 80 degrees of arc caught on the big side and 40 degrees of arc on the small side, we're going to just be taking the average. Half the sum is average, right? Jordan is excellent at calculating in his head. What are we getting here, Jordan?
120 times a half is 60.
He's saying 60. And like we said, they have to be the same. They're vertical. They're opposite angles. So that's what Jacob and I would have you remember about angles with their vertex in the interior. What's the next one about, Jacob?
The measure of an angle formed by two lines that intersect outside a circle is half the difference of the measures of the intercepted arcs.
All right, let's recap here. We've done vertex at the center, vertex on the rim, vertex somewhere inside. The only thing left is vertex outside. So I'm just going to sketch one of those. If you have an angle with its vertex outside, it catches two pieces of arc. Catches a small piece close and a bigger piece farther. And instead of half the sum, Jacob says half the difference. So I'll write half the diff. You're going to go big minus little and divide by 2. Brandon's going to help me. Brandon, we're after that angle that I just dotted there. And if we know the far one here is 140 degrees of arc, and the near one is, let's say, 40 degrees of arc, what would be half the diff? Yes, he did that in his head. He did 100 minus 40 in his head, kids. Don't laugh. Some people don't. But he's right. That's going to have to be 50. So now we've got vertex at center, vertex on rim, vertex somewhere inside, vertex somewhere outside. We've got plans for all the places you could put the vertex of an angle. Is there anything else they can throw at us, Jacob?
Yeah.
What?
For a given point and circle, the product of the length of the two segments from the point to the circle is constant along any line through the point and circle.
I think you're talking about how long those segments are. There's like 3 cases they've documented there, isn't there?
Yep.
One of the cases is 2 chords. This is case one of segments crossing inside of a circle. If you have two chords crossing inside of a circle, piece times piece equals piece times piece. And this one, 3 times 4 has to equal 2 times 6. Which means they could leave one out, right? They could make you find one. So they could just leave this one out right here if they wanted. They could just make that X, and you would have to put an X there, and hopefully you're good enough with your algebra yet that you can figure out 6. Then there's a second case of this theorem where they have like two secants crossing. Here's two secants crossing. What was that? That was a Apache helicopter going over. And shooting. All right, in this one we have an X and a W.
Oh, goodness.
And a Z and a Y. Like this?
That looks about right, Mr. Moore.
Hope I did that right. No, I didn't do that
You
right.
didn't do that right. You need to reverse it.
Is there like a little algebra formula to go with this one, Jacob?
Yep.
How can we calculate these pieces, the relationship between these pieces?
W plus X, and then times W equals Y plus Z times Y.
I'm thinking that's going to be kind of hard for a person to remember. The way I remember it is outside piece times whole thing equals outside piece times whole thing. Watch me write as I repeat that. Outside piece times the whole thing equals outside piece times the whole thing. So that'll be the plan you're following. They will try to leave one of those out so that you have to calculate it. So they're going to turn that into an algebra problem for you by giving you numbers for some of those letters. And then you're just going to have to try to remember your algebra from last year. Actually, we've been reviewing it some, so you're doing okay on that. There's one more case, isn't there,
Yes,
Jake?
sir.
Instead of two secants, I think we're talking a secant and a tangent. So the picture for it looks like this. This one would be a tangent then that just touches the edge of the circle. And we've got
Make
T.
sure you get these right.
I think I can learn.
Well, you kind of messed up on the other one.
Why do you have to say that right here on film?
Sorry.
All right. Can you tell me the formulary relationship between these?
Yeah. Y plus Z times Y equals T squared.
All right, I'd just like to say that isn't real hard to remember because you can just use the same plan I just mentioned. Outside piece times whole thing equals outside piece times whole thing. Watch me as I write that. Outside piece times whole thing equals outside piece times whole thing. T is the whole thing. It still works. It still works. So those are our kind of 5-part lesson for today. That's it for our lesson, isn't it there, Jake?
Yes, sir. It's time to get started.
It's time to start our lesson. So this is Boer saying goodbye. And there's Jacob saying goodbye. All right.